The universe feels familiar because it is all we have ever known. Every morning the sun rises, every evening darkness quietly settles across the sky, and time appears to move forward at the same steady rhythm. We walk across solid ground without questioning why it supports us. We switch on a light without wondering what light truly is. We look up at the stars believing they are simply distant points decorating the night sky. Yet beneath these ordinary experiences lies a reality so extraordinary that it challenges nearly every instinct we have about the world. The deeper scientists have explored nature, the more they have discovered that the universe is far stranger than it first appears. Physics is not merely a collection of mathematical equations or scientific theories. It is humanity's attempt to uncover the invisible rules that govern everything, from the tiniest particles hidden inside atoms to the largest structures stretching across billions of light years. Every discovery reveals another layer of mystery, reminding us that reality is often far more fascinating than imagination itself. One of the greatest surprises begins with something that appears to be completely empty. Imagine removing every planet, every star, every grain of dust, every atom, and every molecule from a small region of space. Most people would naturally describe what remains as absolute nothingness. For centuries, this seemed perfectly reasonable. However, modern physics tells an entirely different story. Even a perfect vacuum is never truly empty. Invisible quantum fields fill every corner of the universe, extending through space like an endless fabric that cannot simply be switched off. These fields never remain perfectly still. Instead, they constantly fluctuate, producing tiny bursts of energy that appear and disappear in unimaginably short moments. Although these fluctuations are incredibly small, their effects have been measured in laboratories with astonishing precision. This means that what we call empty space is actually alive with hidden activity. Beneath the silence of the vacuum lies a restless universe where invisible processes continue without pause, reminding us that even nothingness possesses remarkable complexity. This discovery changes the way we think about reality itself. Empty space is not merely the stage upon which the universe performs its grand events. Instead, it is an active participant in the story. Every galaxy, every planet, every beam of light exists within a cosmic framework that never truly rests. The vacuum of space may appear peaceful from a distance, but beneath that calm surface, countless quantum events unfold every second. Although we cannot see them with our eyes, they influence the behavior of matter in subtle yet measurable ways. Reality, it seems, is built upon layers hidden far beyond ordinary human perception. Another idea that feels completely natural is the passage of time. Every clock around us appears to tick at the same steady pace. Seconds become minutes, minutes become hours, and days quietly pass into memories. Because everyone experiences this rhythm throughout life, it seems obvious that time flows equally for every observer. Yet one of the greatest scientific discoveries of the 20th century revealed that this comforting belief is not entirely true. Time is not fixed. It bends, stretches, and changes depending on gravity and motion. According to Einstein's theory of relativity, a clock placed on Earth's surface actually ticks slightly slower than another clock positioned far above the planet. The difference is incredibly tiny, but today's atomic clocks are so accurate that they measure these changes with ease. Modern navigation systems rely on correcting these tiny differences every single day. Without accounting for the changing flow of time, even the maps on our smartphones would gradually become inaccurate. Gravity, therefore, does much more than keep our feet firmly on the ground. It reshapes space and time themselves. Near extremely massive objects such as neutron stars or black holes, this effect becomes astonishingly powerful. Imagine spending only a short period close to one of these enormous objects before returning home. While only hours may have passed for you, many years could have passed for people waiting far away. This idea sounds more like the plot of a science fiction film than genuine science, yet countless experiments have confirmed that gravity truly influences the passage of time. Every clock experiences its own version of reality depending upon where it exists within the universe. Light presents another mystery that has puzzled scientists for generations. It fills our world with color, reveals distant galaxies, and allows every living creature to see its surroundings. For centuries, people assumed light behaved like a continuous wave moving through space, much like ripples spreading across a quiet lake. Later experiments suggested something entirely different. Light also behaves as though it consists of tiny individual packets of energy known as photons. At first, this seemed impossible. How could something be both a wave and a particle at the same time? The answer lies within the strange world of quantum mechanics. Light refuses to fit neatly into categories created by everyday experience. Depending upon how scientists observe it, light can display the characteristics of waves or particles, revealing that nature often follows rules unlike anything encountered in ordinary life. Perhaps the most famous demonstration of this strange behavior is the double-slit experiment. When light passes through two narrow openings, it creates an interference pattern resembling waves spreading across water. Surprisingly, this pattern still appears even when photons travel through the experiment, one at a time. It is almost as though each photon somehow explores multiple possibilities before finally arriving at its destination. Scientists continue to investigate the deeper meaning of these results, yet one conclusion remains undeniable. Reality on the smallest scales behaves in ways that challenge our everyday intuition. The microscopic universe follows rules unlike anything visible in our daily lives. Equally astonishing is the hidden structure of matter itself. Everything around us appears solid. The chair supporting your body feels firm. Stone walls seem impenetrable. Your own hands appear dense and substantial. Yet nearly all matter consists mostly of empty space. Every atom contains a tiny nucleus surrounded by electrons, occupying a region vastly larger than the nucleus itself. If an atom were enlarged until it became the size of a giant sports stadium, its nucleus would occupy only a tiny space near the center, while almost everything else would remain astonishingly empty. Despite this, billions upon billions of atoms combine to create the illusion of complete solidity. The reason your hand cannot pass through a table has little to do with matter being completely filled. Instead, invisible electromagnetic forces prevent the electrons within your body from occupying the same space as electrons within the table. The sensation we describe as touch is actually the result of these tiny electric interactions. Without them, the world would be unrecognizable. Every object around us owes its apparent solidity not to densely packed material, but to invisible forces operating continuously at the atomic scale. The deeper we examine nature, the clearer it becomes that our senses reveal only a tiny fraction of reality. Human eyes evolved to detect a narrow range of visible light, yet countless other forms of electromagnetic radiation surround us at every moment. Radio waves carry conversations across continents. Microwaves warm food by exciting water molecules. Infrared radiation quietly leaves every warm object, while X-rays and gamma rays possess enough energy to reveal hidden structures deep inside matter. None of these forms of light are visible to us naturally, yet they fill the universe just as completely as the colors we see every day. Our understanding of reality depends not only on what our senses perceive, but also on the remarkable instruments that allow us to explore beyond those natural limits. As scientists continued investigating the universe, Every answer seemed to reveal even greater mysteries waiting beyond it. The closer they looked at atoms, the stranger matter became. The farther they observed into space, the more astonishing the cosmos appeared. Every discovery suggested that reality is far richer, more complex, and more beautiful than anyone had imagined. What once seemed impossible gradually became accepted scientific knowledge, proving that the universe often exceeds even our boldest imagination. And this is only the beginning of our journey. Beyond the familiar world lies a cosmos, filled with invisible forces, extraordinary objects, mysterious particles, and astonishing phenomena that continue to reshape our understanding of existence itself. As scientists expanded their understanding of the universe, they discovered that some of the most extraordinary objects in existence are not the largest galaxies or the brightest stars, but the incredibly dense remains of stars that have already reached the end of their lives. Among these remarkable objects are neutron stars. When a massive star exhausts the nuclear fuel that supports it against gravity, its core collapses with unimaginable force. Matter is compressed so intensely that atoms themselves can no longer survive in their ordinary form. Electrons and protons are forced together, creating a gigantic sphere made almost entirely of neutrons. The result is an object only about 20 kilometers across, yet containing more mass than our Sun. The density is almost impossible to imagine. A single teaspoon of neutron star material would weigh billions of tons on Earth. Gravity there is so powerful that mountains could never exist as they do here, and even the smallest movement would release tremendous amounts of energy. These incredible remnants remind us that nature can reshape matter into forms completely beyond everyday experience. Some neutron stars rotate at astonishing speeds. As the original star collapses into a much smaller object, its rotation accelerates dramatically. Just as an ice skater spins faster after pulling in their arms, certain neutron stars complete hundreds of rotations every second, while emitting narrow beams of radiation from their magnetic poles. Whenever one of these beams sweeps across Earth, astronomers detect a perfectly timed pulse, giving these objects the name pulsars. Their remarkable precision rivals the accuracy of the finest atomic clocks ever built by humanity. Long before scientists understood their true nature, these regular signals seemed so unusual that some briefly wondered whether they might originate from intelligent civilizations somewhere among the stars. Eventually, careful observation revealed that these astonishing cosmic lighthouses were entirely natural, created by the extraordinary laws of physics. If neutron stars stretch the limits of imagination, black holes push those limits even further. A black hole forms when gravity becomes so overwhelming that not even light can escape its grasp. Contrary to popular belief, a black hole is not an enormous vacuum cleaner wandering through space, swallowing everything nearby. From a safe distance, its gravity behaves exactly like any other object with the same mass. If our Sun could somehow become a black hole without changing its mass, Earth's orbit would remain almost exactly the same. What makes black holes extraordinary is not that they pull harder from great distances, but that an enormous amount of matter has been compressed into an incredibly tiny region of space. Cross a certain invisible boundary, known as the event horizon, and every possible path leads inward. Beyond that point, nothing, not even light traveling at its ultimate speed, can escape back into the universe. The behavior of time near a black hole becomes even stranger than gravity itself. Imagine watching a spacecraft slowly descend toward the event horizon. To the astronauts inside, time would appear perfectly normal. They would continue their journey without noticing anything unusual about their own clocks. Yet, to a distant observer watching safely from far away, the spacecraft would seem to move more slowly as it approached the black hole. its signals would become increasingly stretched toward the red end of the spectrum, growing fainter and fainter until they eventually disappeared from view altogether. This remarkable difference exists because gravity changes the flow of time itself. Two observers witnessing the same event can experience entirely different versions of reality, depending on where they are located within the gravitational field. Another remarkable discovery concerns the speed of light, which represents one of the universe's most fundamental limits. Nothing possessing mass can travel faster than light moving through empty space. This is not simply because our engines are too weak or our technology remains primitive. Instead, it is woven into the very structure of space and time. As an object accelerates closer to light speed, each additional increase in speed requires dramatically more energy than the one before it. Near the ultimate limit, enormous amounts of energy produce only tiny gains in velocity. Reaching the speed of light would require an infinite amount of energy, making it forever unattainable for ordinary matter. Photons, however, naturally travel at this speed because they possess no rest mass. They do not accelerate from rest like rockets or airplanes. They simply exist moving at light speed from the moment they are created. The constant speed of light leads to some of the most surprising consequences in modern physics. Time slows for rapidly moving objects, distances contract along the direction of travel, and events that appear simultaneous to one observer may occur at different moments for another. These effects are far too small to notice during everyday life, yet they become unmistakable when objects travel at extremely high speeds. Scientists observe them regularly inside particle accelerators, where tiny particles survive much longer than expected because their internal clocks run more slowly relative to observers on Earth. What once seemed impossible has become one of the best-tested principles in all of science, demonstrating that motion changes the very fabric of reality itself. Among the greatest mysteries of quantum mechanics lies a phenomenon known as quantum entanglement. Imagine two particles interacting closely before separating by enormous distances. According to quantum theory, these particles may remain connected through a shared quantum state even after traveling far apart. Measuring one instantly determines the corresponding property of the other, regardless of the distance separating them. This strange relationship troubled Albert Einstein, who famously described it as spooky action at a distance. Although countless experiments have repeatedly confirmed the existence of quantum entanglement, scientists have also shown that it cannot be used to send information faster than light. Instead, it reveals that the microscopic world is connected in ways that have no equivalent in everyday experience. Quantum entanglement has become one of the foundations of emerging technologies such as quantum computing and ultra-secure communication systems, suggesting that tomorrow's most advanced technologies may depend upon the same mysterious principles that once puzzled the world's greatest physicists. Gravity itself contains another surprising secret. Compared with the other fundamental forces of nature, gravity is actually astonishingly weak. A simple refrigerator magnet can easily lift a paperclip against the gravitational pull of the entire Earth. Yet, despite its weakness, gravity dominates the largest structures in the universe. The reason lies in its unique nature. Unlike electric forces, which can cancel each other when positive and negative charges meet, gravity only attracts ordinary matter. Every star, every planet, every cloud of gas, and every tiny grain of dust contributes to the same universal pull. Across millions and billions of years, this gentle attraction gathers matter into stars, shapes entire galaxies, and builds the vast cosmic web stretching across the observable universe. What appears almost insignificant in everyday life becomes the architect of the cosmos itself when enough matter and enough time are involved. Light also reveals another extraordinary property of gravity. According to Einstein's theory of general relativity, gravity does not simply pull objects through space. Instead, It curves space itself. Because light always follows the shape of space, its path bends whenever it passes near a massive object. During a total solar eclipse in 1919, astronomers measured the apparent positions of distant stars and discovered they had shifted exactly as Einstein predicted. Since then, scientists have observed this phenomenon countless times throughout the universe. Massive galaxies can act as gigantic natural lenses, bending and magnifying the light from even more distant galaxies hidden behind them. This effect, known as gravitational lensing, allows astronomers to observe objects that would otherwise remain far beyond the reach of even the most powerful telescopes. Once again, the universe demonstrates that space is not an empty stage, but an active participant in every cosmic event. Perhaps the most remarkable aspect of all these discoveries is that they are not isolated curiosities. They are connected pieces of a much larger puzzle. Gravity influences time. Time influences motion. Motion changes the measurement of distance. Light responds to the curvature of space, while quantum particles behave according to rules that challenge our deepest intuitions. Every new discovery reveals another hidden connection, reminding us that the universe is not a collection of separate phenomena, but a single, beautifully interconnected system governed by laws that continue to surprise us. The more carefully we observe reality, the more we realize that even its strangest behaviors follow an elegant order waiting patiently to be understood. Although the universe often appears calm and unchanging, it is constantly moving on every possible scale. Even at this very moment, Earth is rotating on its axis at hundreds of kilometers per hour, while simultaneously orbiting the Sun at nearly 30 kilometers every second. The Sun itself is racing around the center of the Milky Way at an incredible speed, completing a single orbit only once every 230 million years. Meanwhile, our entire galaxy is traveling through the universe alongside thousands of neighboring galaxies. We never notice these extraordinary motions because everything around us shares the same journey. The ground beneath our feet feels perfectly still. Yet we are passengers aboard a planet that has never stopped moving since its formation more than 4.5 billion years ago. The stars scattered across the night sky appear timeless, but every one of them is living through a remarkable story. Like all living things, stars are born, they grow, they change, and eventually they die. Their lives begin inside enormous clouds of gas and dust, drifting quietly through interstellar space. Gravity slowly gathers this material together over millions of years until the growing cloud becomes dense enough for its center to reach extraordinary temperatures. At that moment, hydrogen atoms begin fusing together, releasing tremendous amounts of energy. A new star is born, flooding the surrounding darkness with light and heat. Our own Sun has been producing this energy for approximately 4.5 billion years, and still contains enough hydrogen to continue shining for another 5 billion years. Every sunrise we witness is powered by nuclear reactions taking place deep inside its core, where matter is continuously transformed into energy. The sunlight reaching your face has a fascinating history of its own. Although light takes only about 8 minutes to travel from the Sun to Earth, the energy carried by those photons begins its journey much earlier. Deep within the Sun's core, energy produced through nuclear fusion spends thousands, and possibly even hundreds of thousands of years, slowly making its way outward. Countless collisions with atoms scatter the energy repeatedly before it finally escapes from the Sun's visible surface. Only then does it begin its rapid 8-minute journey across nearly 150 million kilometers of empty space before arriving on Earth. Every beam of sunlight is therefore both ancient and recent, carrying with it a story that began deep inside a star long before it illuminated our skies. As stars continue producing heavier elements inside their blazing cores, they gradually transform the chemical makeup of the universe itself. In the earliest moments after the Big Bang, the cosmos contained almost nothing except hydrogen and helium. The carbon that forms your cells, the oxygen you breathe, the calcium strengthening your bones, and the iron flowing through your blood simply did not exist. These elements were created much later inside generations of stars through nuclear fusion. When massive stars finally exhaust their fuel, many end their lives in spectacular explosions, known as supernovae. During these violent events, enormous quantities of newly created elements are scattered across space, enriching enormous clouds of gas, from which entirely new stars and planets eventually form. Every atom heavier than helium has traveled through the heart of at least one ancient star before becoming part of the world we know today. In a very real sense, every person carries within them the remains of long-dead stars whose light disappeared billions of years before Earth itself even existed. Some of the rarest elements in existence require events even more violent than supernova explosions. Gold, platinum, and several extremely heavy elements are believed to form primarily during collisions between neutron stars. These unimaginable cosmic impacts release tremendous amounts of energy while ejecting neutron-rich material into space, where entirely new atomic nuclei rapidly form. Billions of years later, some of this material becomes incorporated into young planets like Earth. The gold contained within a wedding ring or an electronic circuit may therefore have originated during one of the most energetic events ever witnessed in the universe. Something humans value as precious because of its rarity also carries an extraordinary cosmic history stretching back across billions of years. Yet despite all these magnificent events, much of the universe remains completely invisible. Everything we normally see, stars, planets, moons, galaxies, clouds of gas, and every living creature, accounts for only a small fraction of the universe's total contents. Astronomers studying the motion of galaxies discovered something deeply puzzling. Galaxies rotate far too quickly for the visible matter they contain. According to gravity alone, many stars should simply fly away into space. Instead, galaxies remain stable, suggesting that enormous amounts of invisible matter surround them. Scientists call this mysterious substance dark matter. It neither emits light nor reflects it, making it completely invisible to ordinary telescopes. Although no one has directly observed dark matter itself, its gravitational influence appears throughout the universe. It acts as an enormous hidden framework upon which galaxies assemble, quietly shaping the large-scale structure of the cosmos. Even more mysterious is another phenomenon known as dark energy. During the late 20th century, astronomers carefully measured the expansion of the universe and expected gravity to be slowing that expansion over time. Instead, they discovered something astonishing. The universe is expanding faster today than it did billions of years ago. Something appears to be pushing distant galaxies away from one another at an ever-increasing rate. Scientists named this unknown influence dark energy, not because they understand what it is, but because its true nature remains one of the greatest mysteries in modern science. Unlike gravity, which pulls matter together, dark energy seems to influence space itself, causing the fabric of the universe to stretch more rapidly as time passes. Although invisible and impossible to feel directly, it may account for nearly 70% of everything that exists. When astronomers observe the night sky using sensitive microwave instruments, they detect another extraordinary clue about the universe's distant past. In every direction, space glows with an incredibly faint background of microwave radiation. This ancient light is known as the cosmic microwave background, and it represents the oldest light humanity has ever observed. It began its journey nearly 13.8 billion years ago, shortly after the universe became cool enough for atoms to form. Before that moment, the universe was so hot that light could not travel freely. Once atoms appeared, photons escaped into space, where they have continued traveling ever since. Today, those same photons still arrive at Earth as an extremely faint glow spread across the entire sky. This ancient radiation provides scientists with a remarkable snapshot of the infant universe, allowing them to study conditions that existed billions of years before the first stars or galaxies were ever born. Perhaps one of the most humbling discoveries in astronomy is that the observable universe is almost certainly not the entire universe. There exists a limit beyond which we cannot see, not because our telescopes are too weak, but because light has had only a finite amount of time to travel since the beginning of cosmic history. Beyond this observable horizon may lie countless additional galaxies stretching endlessly into space, forever hidden simply because their light has not yet reached us. Observers living within those distant galaxies would possess their own observable universe centered upon themselves, seeing regions forever invisible to us. This realization transforms our understanding of existence. The universe we observe may be only a tiny portion of something vastly larger, extending far beyond anything humanity will ever directly witness. The deeper we explore the cosmos, the more we realize how small our everyday concerns truly are. Every mountain, every ocean, every civilization, and every human life unfolds upon a tiny planet orbiting one average star among hundreds of billions within a single galaxy. That galaxy itself is only one among trillions scattered throughout the observable universe. Yet despite our apparent smallness, the human mind possesses something extraordinary. Using curiosity, mathematics, careful observation, and imagination, we have uncovered secrets stretching across billions of years and unimaginable distances. Every discovery reminds us that, although we occupy only a tiny corner of the cosmos, our desire to understand it has no measurable limit. The universe continues to reveal astonishing truths to those willing to ask questions, and with every answer comes an even greater mystery waiting beyond the horizon. As we journey deeper into the hidden laws of nature, we begin to realize that many of the ordinary experiences of everyday life are quietly shaped by extraordinary physics. A glass of water resting on a table appears completely ordinary, yet the molecules inside it are constantly moving. Even in water that feels perfectly still, billions upon billions of tiny molecules are vibrating, colliding, and exchanging energy every second. Temperature is simply our way of describing how energetically these particles move. Heat is not an invisible substance flowing through an object. Instead, it is the continuous transfer of energy between countless moving particles. The warmth of sunlight on your skin, the steam rising from a cup of tea, and the cold breeze of winter all originate from the invisible dance of atoms too small for our eyes to see. Water itself behaves in ways that make life on Earth possible. Most substances become denser as they cool, causing solids to sink beneath their liquids. Water does something remarkably different. As it freezes, its molecules arrange themselves into an open crystal structure that occupies more space than liquid water. This is why ice floats instead of sinking. At first glance, this may seem like an unimportant detail, but its consequences are enormous. During winter, lakes and ponds freeze from the surface downward, rather than becoming solid blocks of ice from the bottom upward. The floating layer of ice acts as insulation, allowing liquid water to remain beneath it, where countless forms of life continue to survive until warmer seasons return. One unusual molecular property quietly protects entire ecosystems across our planet every single year. Pressure also changes the way water behaves. Most people associate boiling with extremely high temperatures, yet boiling depends on pressure just as much as heat. At sea level, Water boils at 100 degrees Celsius because atmospheric pressure pushes against escaping water vapor. Reduce that pressure sufficiently, and water can begin boiling even at room temperature. Inside a vacuum chamber, water bubbles vigorously despite remaining relatively cool. This surprising effect demonstrates that boiling is not simply the result of heating a liquid. It occurs whenever vapor pressure becomes strong enough to overcome the surrounding pressure. On high mountains, where air pressure is lower, water boils at lower temperatures, changing everything from cooking times to weather patterns. Another invisible force quietly surrounds us every day: magnetism. Magnets seem almost magical because they attract or repel objects without making physical contact. Their remarkable behavior originates from one of the smallest particles in nature, the electron. Every electron possesses a tiny magnetic property known as spin. In most materials, these miniature magnets point in random directions and cancel one another. In certain metals, such as iron, however, enormous numbers of electrons naturally align together, creating magnetic regions called domains. When enough of these domains point in the same direction, the entire object becomes a magnet. The simple act of attaching a note to a refrigerator is therefore the visible result of countless quantum-scale particles acting together with astonishing coordination. Electricity is equally remarkable. Every second, billions of electrons move silently through wires inside our homes, carrying energy over enormous distances. In ordinary conductors, these electrons collide constantly with atoms inside the material, producing heat as they travel. This is why electrical devices become warm after extended use. Under extraordinary conditions, however, certain materials enter a state known as superconductivity. When cooled to extremely low temperatures, electrical resistance disappears completely. Electric current can continue flowing for years without losing measurable energy. Superconductors also possess another astonishing ability. They repel magnetic fields so effectively that magnets can appear to float above them without any visible support. These strange materials may one day revolutionize power transmission, transportation, and medical technology if scientists discover practical versions capable of operating at everyday temperatures. The strange behavior of the quantum world continues to challenge our understanding of reality. One of its most fascinating phenomena is quantum tunneling. In everyday experience, a ball rolling toward a hill without enough energy simply rolls back down. Quantum particles, however, do not always obey such familiar rules. Their wave-like nature allows them a small probability of appearing on the opposite side of barriers that classical physics says they should never cross. Although this sounds impossible, quantum tunneling occurs naturally throughout the universe. It plays an essential role inside the Sun, allowing nuclear fusion to occur efficiently enough for stars to shine. It also enables technologies such as scanning tunneling microscopes, which can produce images of individual atoms. Nature occasionally allows particles to accomplish what appears completely impossible from the perspective of everyday experience. Our own planet also provides countless demonstrations of physics at work. Lightning, for example, is among the most energetic natural events visible from Earth's surface. Within storm clouds, enormous electrical charges gradually build until the surrounding air can no longer resist them. Suddenly, a brilliant electrical discharge tears through the atmosphere, heating the air to temperatures far exceeding the visible surface of the Sun. The surrounding air expands explosively, creating the powerful shock wave we recognize as thunder. Although a lightning flash lasts only a fraction of a second, it briefly transforms the atmosphere into one of the hottest environments found anywhere on Earth. Every storm, therefore, becomes an extraordinary display of electrical physics unfolding above our heads. Even the colors surrounding us owe their existence to invisible physical processes. A rainbow is not an object suspended in the sky, but a beautiful consequence of sunlight interacting with countless tiny droplets of water. As sunlight enters each droplet, it bends, reflects from the inner surface, and bends once more while leaving. Because different wavelengths of light bend by slightly different amounts, white sunlight separates into its familiar spectrum of colors. Every observer sees a unique rainbow formed by a completely different collection of raindrops. In this sense, no two people ever observe exactly the same rainbow, even while standing side by side. Nature creates an entirely personal display for every pair of eyes looking toward the storm. Human vision itself represents only a tiny window into reality. Our eyes detect a narrow band of wavelengths known as visible light. Yet this range forms only a small portion of the electromagnetic spectrum. Beyond red lies infrared radiation, emitted by every warm object. Beyond violet lies ultraviolet light, followed by X-rays and gamma rays carrying far greater energy. At longer wavelengths exist microwaves and radio waves carrying television broadcasts, satellite signals, and wireless communication around the globe. The universe is therefore flooded with forms of light that remain permanently invisible to human eyes. Only through scientific instruments have we learned to observe these hidden regions of reality, revealing a cosmos far richer than natural vision alone could ever imagine. Perhaps the greatest lesson physics teaches is one of perspective. The universe is not designed according to human intuition. It is under no obligation to behave in ways that feel comfortable or familiar. Time can slow, space can bend, particles can exist as probabilities, and invisible forces can shape galaxies across billions of light years. Every discovery expands our understanding while revealing how much remains unknown. Questions that once seemed impossible gradually become measurable, and mysteries once dismissed as fantasy eventually become established scientific knowledge. Curiosity has carried humanity from wondering about the stars to measuring gravitational waves produced by colliding black holes billions of light years away. Each generation inherits a deeper understanding than the one before. Yet the horizon of mystery continues to stretch farther into the distance. As we reach the end of this journey, one truth becomes beautifully clear. The universe is not strange because it seeks to confuse us. It is strange because reality is far richer than our everyday senses were ever designed to perceive. Every heartbeat, every ray of sunlight, every falling raindrop, and every distant galaxy follows elegant laws that have shaped the cosmos for billions of years. Although we have uncovered remarkable secrets, we have almost certainly explored only a tiny fraction of what remains to be discovered. Somewhere beyond the limits of today's knowledge, new mysteries are already waiting, patiently inviting future generations to continue the endless search for understanding. The more we learn about the universe, the more we realize that its greatest wonder is not simply how vast it is, but how endlessly surprising it continues to be.